Vertical and horizontal translations. So a translation is an operation that shifts a graph horizontally, vertically, or both. It results in a graph of the same shape and size in different positions. All right, same shape and size in different positions. And so they have what's called parent functions. If you look at this first graph, it says compare the graphs of y equals absolute value of x, y equals x minus 3. Describe how the graphs of those two relate. All right, and so this is something that you're going to be doing actually with lots of graphs, not just the absolute value graph. And so the parent function, that it would be this y equals absolute value of x. The parent function is the function that is not changed. All right, it is like the original function with no plus or minuses, no multiplication. It just is y and x compared to each other and what's happening to the x. And in this case, it's absolute value. And so my parent function here is going to be this perfect v that has the one slope on each side. This would be called the parent function. And so there are times when they'll say, what is the parent function for this? And they give you one. And so your parent function would be the y equals absolute value of x. And it would look like this, just like we did on the first one. And then the next one says, compare this graph. So where's my vertex on this next one? Where's my vertex on the, it's actually at 0, -3, right? 0, -3. And so I would go down here to 0, -3. What is my slope of this next graph?
1.
Right, so it's still going to be this guy, all right? So what should happen here is this should look identical to my parent function. It's just moved, right? It's just moved. And so when you do vertical and horizontal translations, what they're doing is they're just taking that parent function and they're just moving it around the graph, all right? And so they give us some examples here. If you go to example 2, example 2 here, we have two different types of parent functions here. In this example, we have a parent function that is a linear equation, which we have learned, right? Y equals x. That is your standard linear equation, meaning your slope is 1 and your y-intercept is 0. Y equals x is just the line straight through the origin with a slope of 1. And then you have your absolute value equation, y equals absolute value of x. Let's look at how they move. So it says let k be a positive real number. To graph the function y equals x plus k and y equals absolute value of x plus k, translate the parent function up k units. To graph the minus k, you translate it down. And so if I were to take just this line here and translate it with a plus or minus, it's just going to take this line and go up and down, right? If I do the same thing with absolute value, plus or minus is going to take this exact equation and it's just going to move it up or down. That is a vertical translation. It just moves it up and down. All right. And so how you see it in the actual form, in the function form, looks like this. Well, if I said graph the line y equals x minus 2, I'm going to go down 2, which is what I would have always done. And I would have graphed my slope, right? It is the same exact line as what we had before. It's just shifted down. So we are doing the same exact thing with our absolute value. Now, with absolute value, you also have to pay attention to this guy, all right? Just like with this, if I had a negative here, it would have flipped it. The negative there also flips it. And so for this one, I'm not going to worry about where my vertex is. I am going to take just my parent function, which is my one slope right here, and I am going to move it. And so I take this and I say, well, how do I move it? Well, this tells me to move it up 3. So I'm just going to go up 3. And then this tells me to do what with it? Well, to flip it. And so I'm going to move it up 3, and then I'm going to flip it up 3, and then I'm going to flip it down. And so instead of doing negative b over 2 over m or whatever that we've been doing, you can actually just shift where that vertex is based on what it tells you. All right? So that is graphing something vertically, graphing it vertically. And I'm not gonna make you do this. So how would I move this guy vertically? What would I move here? Up, down, well, how would I move it? Down 1. What about this one? How would I move this? Up 5. This is what type of equation? A V or a line? It's a V. It's an absolute value. This one is what? This is a line, linear equation. So you need to be able to recognize from the parent function, all right, if I'm looking at this, I'm going to say this tells me my parent function right there. That tells me my parent function, absolute value. I'm going to have a graph that is some V shape, whether it is skinny because I have a sharp slope or whether it's wide because I have a fractional slope. It is going to be some type of V, and I can tell that from my parent equation. The other one, however, is going to be a line because I can also tell that from my parent equation, my parent function there. And so we're starting to add in 2 different functions, but we can now shift them around the graph, all right? You can also write the equations based on what they tell you. Look at the next example. It says, write an equation for this vertical translation. Y equals 2x. That is the original function they're giving you. And they want you to move it 4 units down. Well, I'm going to take the function that they gave me, y equals 2x, and I am going to subtract 4. 4 units down, all right? Look at the next one. The next one they said, all right, the function I want you to move is this one. And I want you to move it 1/2 unit up. 1/2 unit up. So I'm going to start with my original equation. Y equals 1/4 x. And I'm going to move it 1/2 unit up. So just based on verbally what they told me, I can write my equation. And we're going to get, and actually when I quiz you on this, I give you a picture of it. And you have to write the equation. I don't give you the parent function. So try those 2. Write those equations that they've given you. Right, so I should have said y equals absolute value of 3x minus 2. For the next one, my parent function they gave me was 1/3 x. They wanted 3 units up, so I just needed to add 3. Add 3. All right? It's very simple. Let's look at the next example. All right. So the next thing we're going to do is horizontal translations. Horizontal translations are not quite as intuitive. Remember when we did our vertex, we did negative b over m, negative b over m. And so when we had the parent function, everything that we were adding or subtracting was actually on the outside of the function, all right, on the outside. And so when it's on the outside, that is your vertical, that's up and down. When it's on the inside, that is your horizontal, that's your left and right. But it is opposite movement of what you see on the inside, all right? So what you'll notice here, my parent function is this black function here. It's right on the origin. It has the perfect one slope, okay? The red, y equals x minus h, x minus h. It moved it right h units, even though it's minus, okay? Because remember, when we found vertex, it was negative b. We flipped the sign. And so when it is minus on the inside of the function, it moves it right. When it is plus, like this blue one on the inside of the function, you'll notice it moved it left. All right? And so as we look at horizontal translations, what's inside your function tells you how to move it left and right. All right? But just you have to do the opposite of what it's telling you. Look at example 4 at the top of page 93. For each function, identify the parent function and the value of h, then graph the function by translating the parent function. So for this first one, the parent function is going to be just my absolute value function, right? My v, that's my parent function. This is on the inside, plus 3. How am I going to move? Left 3 units. And so I'm going to go over here, 3, and then I am going to graph my v that I have there. Now, when you don't have a slope showing, it is a 1 slope, okay? So when there is nothing in front of that x, it's going to be a 1. All right, let's look at the next one. Negative 2 on the inside. So how am I going to move this one? Right 2. Something else you need to pay attention to. that tells me which direction it's going to point. It's going to point down. So I'm going to go down from my vertex and graph that. Easy enough. All right, so try those. Check understanding number 4. And we wrote the translations for the other ones. You can write them here. This is what they'll look like for me. I'm not actually going to give you the function itself. I'm just going to give you a visual, like a graph. And you have to tell me what happens. And so you just have to pay attention to what kind of graph you have and what it should look like. I will say you do need to look at the slopes here. This is a 1 slope, right? So you need to pay attention to that. Mine will not always be 1 slopes. So you might have some that have different slopes. All right, so this is a 1 slope. We're moving it right 5 units. So I know that on the inside, I'm going to do what? Add or subtract. Yeah, I'm going to subtract. So y equals the absolute value of x. And I'm going to say minus 5 there. All right, easy. So for 7a, they're saying this is a diagonal movement. The reason it's a diagonal is because you have both. You have inside and outside movement. And so when we do this, you are going to graph all of it. So let's look at A. If I look at A, I have a -3 on the inside, a +1 on the outside. So that is telling me I'm going to move it right 3 units, which is here, and then up 1 unit, which is here. And so that is where my vertex is. Now, if we had done this, we would have done -b over m. That would have given me 3 over 1. 3 over 1, which is 3, and then my y value would have been 1. And you can see, there we go, there's my vertex. And so using the translations does the same thing as -b over m. It's the same thing. Looking at my slope is 1. And so this graph is going to look just like that. All right, look at the next one, B. All right, B. This one has 2 movements as well. So if I look at B, I have inside +2, outside -4. I also have a negative, all right? So that tells me, how am I going to move? Where's my vertex going to be just looking at that? Left 2, down 4, and I'm pointing which direction? Down, and my slope is 1. So my slope is 1 there. And it's going to graph just like that. All right. So go ahead and graph check understanding number 7.